Hello. This time I'm back with a question from section 14.6, question 16 of the book, which says find the directional derivative of the function x y squared tan inverse of z at the point 2, 1, 1 in the direction of the vector v, which is 1, 1, 1. Okay, so just a quick review. How do we find the directional derivative of the function in the direction of a vector u? So if u is unit vector, then it is easy. Just you find gradient of f at that point. So let me just add that point a, b, c. Just find gradient of f at that point, a, b, c. Then dot product, it's a vector, you dot product it to the unit vector u. That's it. That's what you need to know to be able to solve this question. Now then the first step is to find the gradient of the function. So gradient of function. I'm going to find for the general point x, y, z, then plug in the point of 2, 1, 1. So gradient of a function with 3 variables is a vector with 3 components, a vector in R3, whose first component is partial derivative with respect to x, second component is partial derivative with respect to y, and third one is fz. Then now we can find partial derivatives. So I have 3 functions multiplied, and there is only one of them which depends on x. So partial derivative with respect to x is y squared tan inverse of z. Partial derivative with respect to y is x times 2y tan inverse of z. And partial derivative with respect to x, z is xy squared. So you have to know what is derivative of tan inverse or arctan. It's 1 over 1 plus z squared. So now basically we have all 3 components, and we have general formula for gradient of f. Time to plug in the components of the point 2, 1, 1. So I have to plug in 2, 1, 1 here. 1. Tan inverse of 1 is pi over 4. So I have 1 squared times pi over 4. 2 times 1. Tan inverse of 1 is pi over 4 again. And here I have 2 times 1 squared over 1 plus 1 squared. So gradient at that point now, you can see it's pi over 4, pi, and 1. So we found the gradient. Now we have to find the unit vector, the direction of the vector v. So the direction of the vector is just the vector divided by its length. In this case, the vector is 1, 1, 1, and divided by its length, which is 1 squared, 1 squared, 1 squared. And that gives me a unit vector, which is the direction of the v, and I can use it in the formula I had before for the directional derivative. That's the direction, that's my gradient now. The directional derivative of f at the point 2, 1, 1 in the direction u is equal to gradient pi over 4 pi 1 dot producted to the direction 1 root 3 1 root 3 1 root 3. And dot product, you find the product of the components and add them. So it's pi over 4 pi over 4 over root 3 plus pi over root 3 plus 1 over root 3, which gives me pi over 4, 5 pi over 4 plus 1. I can simplify more, but that's what we need. And thank you for watching this video.